Okay, this is the first videos for chapter 13.2 integration by substitution. Some of the handouts you may see 176 is the same course as 13.25, and we use the same book, and because I have to work at home, so it's harder to change the handout. I hope you don't mind. So remember, we take chain rule for the derivative, and this is a section that shows you how to undo it with the antiderivative. So when you take a derivative of a chain rule, you take the derivative of the outside functions times the derivative of the inside function, right? So this process helps you to undo the chain rule, or to take the derivative of it. So when you take an integration of a chain rule, it will go back to the original function. Alright, so we use the integration by substitution. So this is the method we're going to use today by simplify the process of taking an antiderivative of to undo the chain rule. Okay, so we have some steps here. So first, you're going to let u equal to the g of x part for this function, and let u equal to the inside functions for the composite functions, and then you need to figure out what is du, and then you substitute u and du back to your functions. Sometimes you may have to adjust the constant parts, and then complete the integration, and don't forget to substitute the g of x back. So it seems like pretty complicated, so let's look at this together and do some example together. So let's see the next page. We're trying to find the integral of these few questions, okay? First one. So I can tell this is chain rule because I have some kind of functions, raised to power, some kind of function raised to power. This is going to be raised to what power? 1/2 power. This one also have some power with a function in it. So those would be your chain rule, okay? So let's see. They say replace the inside part, right? So this is the inside part. I'm going to let that equal to u. So I'm going to let u equal to 2x plus 4. So once you have that, you also need to figure out what is du. So making you to take a derivative of that. So the derivative of that is not that difficult. It's just 2, right? But it's going to be 2 dx. So we're going to need to use that to replace stuff here. So as you can see, 2 and dx is here, right? So I'm going to group them together. So basically, I'm taking integral of 2x plus 4 raised to the 5th power. I'm going to put 2 dx together because this is my du part, right? And this is my u part here. So I can replace this with this and this with this, right? So I have my, this is my du, and then the top part would be my u, right? Okay, so I can rewrite that as taking integral of u to the 5th power, and 2 dx is my du, right? So this is something we have done for the last section. When you do integral like that, that's going to be pulling 1 over 5 plus 1, right? So it's going to be 6, and then you need to add 1 more power too, right? And then don't forget plus c. So that would be 1/6, and now I can put my u back, right? My u was 2x plus 4 raised to the 6th power, and then I just add c. So that's kind of like weird, and if you have never done this before, you may have to practice a little bit. But this is the most simple one we can find first for the practice. Okay, the second one. Again, the inside part is going to be my u, right? So I'm going to use that and set that equal to u. So let u equal to x squared plus 3. So du, taking the derivative of that, would be 2x, right? And don't forget your dx. Alright, so we have this, and 2x dx is here, right? So I can kind of group them together. So we got my x squared plus 3 to the 4th power, and I'm going to put my 2x dx together. So this part is my u, and this part is my du, right? Can you see that? This is the u part. This is the du part. Okay, so I'm going to substitute. That would equal to integral of u to the 4th power, and then 2x dx is du, right? So this is something I can take integral of easily. It's going to be 1 over 5 u to the 5th power plus c, right? And then at that point, I can substitute back. My u is x squared plus 3 raised to the 5th power plus c. Are we okay? So kind of all like that. Let's look at the next one. So I'm going to need to rewrite this as integral 3. This thing is 3x plus 1 raised to 1/2 power dx, right? So this is the part that raised to power. So I'm going to let u equal to 3x plus 1. And then du is going to be just 3 dx, right? So that is the part we're going to substitute. So again, if you want to, you can move them, group them together. 3x plus 1 raised to 1/2 power 3 dx, right? So your u is this part, and then the du is this part, right? So I can substitute this as integral of u raised to 1/2 power, and then 3 dx is going to be my du. The integral of that is going to be 1 over that 1/2 need to plus 1, right? So it's going to be 2 over 2. And then u, again 1/2 plus 2 over 2 plus a z, right? So that would give me 1 over 3/2 u 3/2 plus c. So this basically means they flip, right? So we got 2 over 3 u 3 over 2 plus c. And then at this point you can plug it back. The u as 3x plus 1 raised to 3/2 plus a c, right? That's it. Are we okay? Alright, so if you have any question, feel free to email me, okay? So the next part, which part is my u? The u is the one raised to some power, right? And then the du part, probably that, I don't know yet. So let's take the let u equal to the inside of a power, x cubed minus 2x. Okay, so du equal to 3x squared minus 2, right? So that part, hopefully you are pretty good with. So it still look like that's what I have, so that looks good. That's the green part, du, and that's my u. Okay, so I can substitute back in, and if anytime you want to stop the video and try it, you feel free to do it. This would be my u to the 2nd power, and then this part is my du, right? Alright, so this is not too difficult to take the integral. It's going to be 1 over 2 plus 1, and then u also 2 plus 1, which is 3, plus c. So 1/3 u to the third power plus c. At that point, you can plug the u back in, which is x cubed minus 2x raised to the third power plus c, right? Alright, so that's it. So these are the more straightforward type. So the next page, we have things slightly more complicated. So let's see. Next page. Okay. So number 5 here. So I can tell this is my u because it's raised to some power, right? So let's do this. Let u equal to x cubed plus 1. And du is going to be 3x squared plus 0. So that's it, right? So this would be dx. All right. Let's look at here. So if you look at here, we got the x cubed plus 1 raised to 3 half power, which is this part, right? But on the next part, if we group them together, it doesn't look exactly like here, right? Du is 3 times x squared dx. I don't have that. I don't have a 3 here. So what you need to do is, because that's what we have here, and from my questions, I need to see x squared dx, right? But I have an extra 3 here. I need to get rid of this 3. So if I need to get rid of the 3, we can divide both sides by 3. So if you divide this side by 3, and then you divide this side by 3, then this will be gone, right? So in other words, this means 1/3 du will equal to x squared dx. So it requires a little bit more work, so this part will match. So this is the more difficult part compared to the first few examples. And again, this part is my u, right? So again, because once we do the du, it doesn't match what we have in the questions. It has an extra 3 times here, so we divide both sides with 3 to make it look the same. So when we substitute this part, it will be 1/3 of du, okay? So I'm going to be ready to do it now here. So taking integral of u raised to 3 half, and then the x dx is 1/3 du, right? Okay, so what you can do is you can pull the 1/3 out because it's just a constant, right? And then you have u raised to 3 half power du, and then take integral from there. So the 1/3 just hang out, and then it's 1 over this 3 half plus 2 over 2 plus 1, right? And then u, again, 3 half plus 2 over 2, and then add a c, right? Okay, so what do we get? 1/3 times, this is 1 over 5 half, u 5 half, plus a c. Why did I do that? Sorry. So the 1/3 should belong to everybody. Okay, so this is more accurate. But it doesn't really matter because the c can be any number, so I guess it doesn't matter. Okay, so forget it. So either way is okay. C is going to be any number. Okay, so then what do we do? This is 1/3 times, this is going to be, flip it, right? 2 over 5, u 5 over 2 plus the c. So when they multiply together, we have 2 over 15, and then can I go ahead and replace my u? My u can turn it back to x cubed plus 1, and then raised to 5 half plus a c. And c can be any number, so That's it. So things are getting more difficult, as you can see. The next one, we have a negative exponents here for e. So for e is a little bit different, so it's going to be let the u equal to negative 3x. So remember when you have natural functions, if you have a function up here, so that's that. And then if we do du, it's going to be negative 3, right? dx. Okay, so let's see what happened. So I can do integral of e, and this is u, right? And then, same thing, right? I don't have negative 3 here, so I need to do the opposite of that, which is divided by negative 3 both sides. Or you can think of multiply 1 over negative 3 both sides to get that out of the picture. So divided by negative 3 divided by negative 3. So negative 1/3 du equal to dx. So dx is here, will be this guy. So I'm going to have negative 1/3 du, because the u will be du, x will be dx, right? Alright, so let's see. I can pull out the coefficient, right? So negative 1/3 pull out. This is e to u du, right? So taking integral of that is just e to the u, right? So equal to negative 1/3 e to the u power plus the c. So don't forget to substitute back with the u. So final answer would be negative 1/3 e raised to negative 3x plus the c. Alright, so that is the answer. Okay, sorry, they all went into together. So this part is the answer. Alright, how about the next one? So the next one, I have to be careful and rewrite this in this way. So if I have a denominator, this means x times 3x squared plus 1. This is raising to what power? Negative 1 power dx. And then because of the negative 1 power, that makes this a chain rule. So I'm going to let u equal to 3x squared plus 1. And then du is going to be 6x dx. And I don't have a 6, right? So I need to get rid of the 6 by dividing both sides by 6, right? So that means I have 1/6 du equal to x dx. So I'm going to use that, and then let's try this over here. We're going to have, let me group them together first. So 3x squared plus 1 raised to negative 1. This is x dx. So after I substitute, this would be u raised to negative 1 power, and then x dx is going to be this part, right? That's going to be 1/6 du. Alright, so the coefficient can pull out. 1/6 got out. We're taking integral of u negative 1 power du. So I have to be careful with this part. Because if I do it the normal way, 1/6, this would be 1 over, pull down the negative 1, adding a 1, right? And then u will be negative 1 plus 1, and then you're going to add a c, right? Okay, so what happened here? You get a 0 in the denominator. This will make the whole thing undefined, right? So this is not okay. You cannot do it like that. But remember, if it's like 1 over u, that's a special one, right? So if we have 1 over 6, This is 1 over u du. This is actually ln of x, right? So this is one of the one that a lot of students like get confused because they forgot this is ln. So this is just to the -1 power. So when you have -1 power or 1 over some denominator that with the integral, it will turn into ln. So basically this means 1/6 ln of u plus the c, and then 1/6 we can put the u back, which is 3x squared plus 1, and then add a c. So your books say because it's like multiplying something square is always positive, adding a 1 is always positive, instead of putting the absolute value, you can just say 3x squared plus 1 and then add a c. This is because no matter what x is, 3x squared plus 1 will always be positive, okay? Alright, so just be extra careful when you have things raised to -1 power, okay? Alright, so the next one look kind of complicated also, right? Let's try to do that together. We have, let's see, I can rewrite that as ln of x squared, and this bottom part would be I'm not sure, so let this part ln of x be my u first, and let's see how it look like for the du. So if this is ln of x, to take the derivative, du is going to be 1 over x dx, right? So I need 1 over x dx, so I'm going to separate this as 1/2 times 1 over x dx, right? Are we okay with that? Okay, so this is my u, and then this is my du. Okay, so let's see, I don't need the 1/2, but I can put a 1/2 to the front, right? So I can say 1/2 go out, and then ln of x will turn into my u squared, and then 1 over x dx is my du. So that solves every problem. Alright, so now I can take integral, so it's going to be the 1/2 is outside, and then inside here we got 1 over 2 plus 1 u 2 plus 1, and then add a c. Like the c go with the 1/2 or not doesn't matter, the c is c. So it's going to be 1/2 times 1/3 u to the 3rd power plus c. So eventually this will be 1/6 u cubed plus c. I can just plug it back in for my u. So u is ln of x. This is to the 3rd power plus the c. So this one I don't know if it will turn positive or negative, so I leave the absolute value there. Alright, so that's the first video for taking integral by substitution.